Okay everyone, we're going back to adding today, and we're just going to look at adding mixed fractions. Now the reason this is a little bit hard to teach is because there's two methods to teach this, and some people like the one method and some people like the other method. So I'm going to teach them both. I'll tell you which one I prefer. I'll tell you that most of my students don't use the one that I prefer, but you'll have to decide for yourself. So method one is to convert mixed fractions into improper. The problem with this method is some of your numerators may be quite large, but this is the method that most students, I would say, use. Whenever they see mixed fractions, whether it's adding, subtracting, multiplying, or dividing, they always switch it into improper fractions. And that'll work. I mean, with multiplying and dividing, you have to switch them into improper fractions, and you can do it for adding and subtracting too. I just don't like doing it, usually, because sometimes you get really big numerators and it can get kind of unwieldy. But it does work. I mean, let's look at these two questions. If you wanted to know what 2 1/5 plus 3 2/5 is, you could definitely switch it into improper form. 2 times 5 is 10 plus 1 is 11 over 5. Keep the denominator the same. Plus 3 times 5 is 15 plus 2 is 17 over 5. Okay, now remember, when we add, we always need common denominators. And we have common denominators. That's great. The denominator is just going to stay the same. And we add the top. 11 and 17 is 28. So that's good. Or if you want, switch it into mixed. 5 goes into 28 5 times. That gets you up to 25. And you still have 3 left over. Denominator stays the same. So either one of those is great. That wasn't so bad, was it? You know, it's not a bad method to switch them into improper every time. Let's do another one where we use this method, where you just switch them into improper. So I'm going to start by switching them right away. 3 times 4 is 12, plus 1 is 13 over 4. And 2 times 6 is 12, plus 5 is 17 over 6. Now, we need a common denominator. So what do? We take the bigger number, which is 6, and count by 6. 6, 12, 18, 24. Then ask yourself, does 4 go into 6? Nope. Does 4 go into 12? Yes, so that's my lowest common denominator. So what I want is two new fractions that have 12 and 12 on the bottom. So what do you multiply 4 by to get 12? 3. So you got to do the same at the top. What do you multiply 6 by to get 12? 2. So you got to get the same on the top. Now here's what I'm talking about. You get some big numerators. These ones aren't that bad. You can get a lot worse than this. So for example, 13 times 3 here is 39. And 17 times 2, I mean, it's getting a little bit difficult, but not too bad, is 34. Now we have common denominators, so we keep the denominator the same and add the numerators. 39 plus 34 is 73. So we're done. If you want, make it mixed. 12 goes into 73 6 times. That gets you up to 72, and you still have 1 left over. All right, great. I bet most of you use that method. It's a good method. It's just not my preferred method. I prefer method number 2, which is don't change them. Keep them the same. Now, the good news is you avoid some of those giant numerators that you encounter sometimes with the first method. The bad thing is you have to learn how to convert an improper fraction to mixed in your answer. It might sound a little confusing. You'll see what I mean in a second. Also, why is there an extra space there? I don't like that. That bothers me. All right, so I'm going to do the exact same questions. See, 2 1/5 plus 3 2/5, 2 1/5 plus 3 2/5. Now, I want to show you how fast I could answer this question. Remember what we did up here? Just take a look. See, we changed it in improper, blah, 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 did all this stuff, right? Watch how fast I could answer this if I don't switch it in improper. Here's what you do. You add the fractions together. 1/5 plus 2/5. Hey, we already have common denominators. 1/5 plus 2/5 is 3/5. Then add the whole numbers together, the big numbers. 2 and 3 is 5. Okay, I'm done. That's it. 5 and 3/5. 5 and 3/5. You get the same answer. That was so fast. Why bother doing all this improper fraction stuff? Now, it's not always that fast, but it can be. So let's take a look at this one. It won't be as fast, obviously, because we don't have common denominators. But here's how you do this one. Again, it's the exact same question as up here. 3 1/4 plus 2 5/6. 3 1/4 plus 2 5/6. So you need common denominators. What's our lowest common denominator? Well, let's count by 6. I know we just did this. I'll just go through the motions again. Okay, does 4 go into 6? No. Does 4 go into 12? Yes. So that's our lowest common denominator, just like it was up there. So we're going to have 3, that doesn't change, and something over 12, plus 2, and something over 12. Now, what do you have to multiply the 4 by to get 12? 3. So do the same to the top. What do you multiply the 6 by to get 12? 2. Do the same to the top. So what are our new numerators? We have 1 times 3 here, so you get 3. And you have 5 times 2 here, so you get 10. Now we're good to go. Add the, it doesn't matter the order you do it, I'll add the big numbers this time. 3 plus 2, 5. Add the fractions now. 3 twelfths plus 10 twelfths, well they have the same denominator, 12, and 3 plus 10 is 13. Done, right? No. So this point I'm making here, this is why some people don't like it. Because you end up with kind of a weird fraction. It's mixed, but what's weird about it is this part of the fraction here is improper. You don't want to have a mixed fraction with an improper fraction in it. So how do you deal with this? Well, what you do is you just look at that highlighted part for a second. Let's switch that highlighted part into a mixed fraction. So ignore the 5. Don't even look at the 5 for a second. 13 over 12. What's that as a mixed fraction? Well, 12 goes into 13 one time. And how much is left over? Just 1 to get up to 13. The denominator stays the same. So we have 1 and 1/12. So really what you have is 5 plus another 1 and 1/12. Oh, well 5 plus 1 is 6. I have 6 and 1/12. That's my answer. And if you look up here, that's exactly what we got there. Now to me, that's not so bad. I don't mind doing that. It doesn't really bother me. So that's why I love this method. You avoid big numerators. It can be a lot faster in some cases. If you don't like this idea of having to, deal with the improper fraction inside of the mixed fraction, then this isn't the method for you. So I don't know what to do because I don't know how many of you are going to like the first method and how many are going to like the second method. So what I'm going to do is 4 questions, and I'm going to do it both ways. You can see same question here and here. I'll do it both ways. Here and here, both ways, etc., etc. So on the left-hand side, I'll do the switch to improper. Make it improper. And on this one, I'll do the keep mixed. Okay, this is my preferred one, is the keep mixed. All right, I'll go back and forth and back and forth. So you can definitely skip parts of the video if you don't like one of my methods or whatever. All right, the first one. We want to make them improper on this column. So 6 times 4 is 24, plus 3 is 27 over 4, plus 2 times 4 is 8, plus 1 is 9 over 4. Oh, hallelujah. We already have common denominators, so that'll stay the same. And we add 27 and 9, and we get 36. Oh, we can put that in lowest terms. What can you divide them both by? You could divide them both by 4. Divide this by 4, and divide this by 4. You end up with 36 divided by 4 is 9. 4 divided by 4 is 1. Wait a minute. 9 over 1, that's just the same as 9. That is the answer in this case. All right, let's do the same question again, but we'll do it my way, where you don't switch it. So we already have common denominators, so we're laughing. We add the big numbers, 8. Then we add the fractions. 3/4 plus 1/4 is 4/4. Well, wait a minute. This 4/4 right here, what's that the same as? 4/4 is the same as 1. So really what we have is 8 plus 1 is 9, and we're done. I'd say that was a little less work, people. I kind of like saving steps if I can. All right, second one, switch to improper. 3 times 5 is 15, plus 1 is 16 over 5. And 2 times 2 is 4, plus 1 is 5 over 2. We need a common denominator. Take the biggest one, which is 5, and count a little bit, or look down your times table. Does 2 go into 5? No. Does 2 go into 10? Yes. So that is our lowest common denominator. We want something over 10 plus something over 10. What do you multiply 5 by to get 10? 2. Do the same here. What do you multiply 2 by to get 10? 5. Do the same here. So some somewhat big numerators here. 16 times 2 is 32, and 5 times 5 is 25. All right, keep the denominator the same in your answer, and add 32 and 25. That is 57. Put it in mixed if you want. This is fine though, if you want to leave it like this. But 10 goes into 57 5 times. That gets you up to 50. You still have 7 left over. So either one of those are great. Alright, let's do it my way. So you need common denominators of 5 and 2, and we already found it. It's 10. So it's going to be 3 and something over 10. I'm biasing you because I'm going even faster since I don't need to find the common denominator. I already found it. That's not fair, is it? And 2 and something over 10. Alright, what do you have to multiply 5 by to get 10? 2. So do the same at the top. What do you multiply 2 by? 5. So do the same at the top. Our new numerators. 1 times 2 is 2, and 1 times 5 is 5. Now we're ready to add. 3 plus 2, the big numbers, is 5. 2 tenths plus 5 tenths, well, the denominator stays the same, and 2 plus 5 is 7. And there you go, there's the answer right there. If you want, you can put it into improper. 5 times 10 is 50, plus 7 is 57 over 10. But I don't see why you would do that. Alright, third one. 7 plus 3 and 5, 6. Okay, now this is ridiculous not to use my method, but I'll do your method if you want. Make them both improper. Well, this is just 7, so let's make it 7 over 1. And then this is 3 times 6 is 18, plus 5 is 23 over 6. Now, you need lowest common denominators. So if we count by 6, 6, 12, 18, does 1 go into 6? Yeah, 1 goes into everything. So we need 6 to be our denominator. What do you have to multiply 1 by to get 6? 6. This one's already 6. Don't do anything. Or if you want, multiply by 1, but it doesn't change anything. So 7 times 6 is 42. 23 times 1 is still 23. We're ready to get our answer. Keep the denominator the same and add 42 and 23. You get 65. This is fine, or make it mix. 6 goes into 65 10 times to get you up to 60, and then you still have 5 left over. So either one of those is good. Yeah, that took a little while. Alright, watch how fast this is, everyone. Alright, 7 plus 3, if we add the big numbers, gives you 10, and we have 5, 6. I'm done. Come on! Why would you do this? That doesn't make any sense. This is why I think knowing both methods is the best of all. Alright, last one. Both methods we'll use. First one, we switch to improper. 8 times 3 is 24, plus 2 is 26 over 3, plus 4 times 2 is 8, plus 1 is 9 over 2. We need the lowest common denominator, so let's count by 3, the big one. 3, 6, 9, 12. Does 2 go into 3? No. Does 2 go into 6? Yes. There's our lowest common denominator. So we want something over 6 plus something over 6. What do we multiply 3 by? We multiply 2 to get 6. So you got to do the same to the top. What do we multiply 2 by to get 6? We multiply by 3 to do the same to the top. Let's get our new numerators. 26 times 2. Ooh, 26 times 2, that's not so easy. It's 52. 9 times 3 is 27. Now we're good to go. Our denominator stays the same. Add 52 and 27 and you get 79. Putting that into mixed form isn't the easiest. 6 goes into 79, what, 13 times? That gets you up to 78, and you still have 1 left over, so 13 and 1, 6. Now, let's try this method. So in this method, we're not going to change them, but we do have to get a common denominator, which we already found was 6. So it's going to be 8 and something over 6, plus 4 and something over 6. What do you multiply? Multiply by 2, top and bottom. Multiply by 3, top and bottom. So our new numerators, 2 times 2 is 4, 1 times 3 is 3. Now we're ready to add. 8 plus 4, for the big numbers, is 12. 4, 6 plus 3, 6. Keep the denominator the same, add 4 and 3, you get 7. What? We didn't get the same answer. Why not? Because this is improper, right? This is no good. You don't want improper in a mixed fraction. So you need to switch that. What's 7 over 6 as a mixed fraction? Well, 6 goes into 7 one time, and you still have 1 left over, still over 6. So really what you have is this 12 here plus the 1 here gives you 13 and the 1, 6. And that's exactly what we got here. Okay, the choice is up to you, people. Do whichever method you like more, or use them both from time to time. I don't mind, as long as you're getting the right answer. Take care.